Okay, we have got to be able to get some data off of this stupid floppy drive. Gotta be able to. So last I checked, let's see. Give ourselves some, oh, let's adjust this a little bit. Give ourselves some floppy power. Give ourselves some Nintendo power. Wait a minute. I know you can do it. Or not. Was it just hanging? Yes, Werewolf, technically still morning. Okay. So I don't quite remember where we were specifically. Like I remember in a broad sense where we were, but were we hanging before? My general thought is that we may have been reading floppy data fine at the beginning of the last stream, but had a bad floppy. We actually, if we get really lucky in the middle of this stream, we may, a thing may arrive in the mail that will very much help us out. But we'll just see. I won't hype that up too much. So anyway, let's do the old review the code and try and remember what is going wrong, I guess. So I don't remember hanging. That's the main thing. Were we hanging? I think maybe. Oh, let's reread the steps. Because I don't remember it hanging. I remember it returning, but having garbage data on it. Hi, Naryan! So, let's do the old classic reread through all the shit and see if I am obviously missing something. So, hardware reset. Literal toggle the reset pin. Wait for an IRQ to fire. 4 times. Send a sense interrupt command, which is command 8. Send it. Read the result bytes twice. Decrement X, loop, so on and so forth. Then send a configure command. The command is 13. Parameter 1 is 0, which I don't remember if they even said what it was, but they said 0. We have polling mode on. You know what we didn't have on before is polling mode. I'm curious. That might be something that I want to try and turn off. Wareham said you may need to check more flags to see if you get data out of the FIFO results. Yes, I agree. That's also kind of where I'm thinking of being at today. But I have to figure out why it's hanging just now. Which might just be... That might just be an accident. Let's just check it again. Let's just, for fun. Because it should eventually go to the prompt. And it's not. And I don't remember that being a thing. And we can't check flags if it's hanging. Because it's hanging. Weird. I'm going to leave that there for a second. Here, I'm going to leave that. And so as to not horribly waste time. We can proceed to look at this in the meantime. Okay. So, just back to making sure that I didn't do anything stupid last time. So, the sense interrupt, then we send the configure command. Again, I was saying, could be polling mode. We weren't using polling mode the last time that we were getting data, but it appeared to be garbage. So, that's a thing. Then pre-comp use default, that's it. We set the data rate to 500, that is fine. Send a specify command to configure like the head load and unload times, that's fine. I don't think that sends an interrupt, so I don't think that's a problem there. Send the version command for no good reason. We used to be using that to actually, check the version to make sure things were working, but we're kind of past that now. Then we do the drive select and turn on the motor. Wait for the motor to spin up by just waiting for a while. Then we do a recalibrate command, which is supposed to seek it back to track 0. Oh, wait, what? Oh, okay. Recalibrate, wait for IRQ, sense interrupt, because you're supposed to follow up a recalibrate with a sense interrupt command, then another recalibrate to shove us all the way back to track 0. Really what you're supposed to do is sit here and wait for the track 0 flag to become active, and just keep doing that until that happens, but whatever. Another sense interrupt, then we do a seek, which I do believe we were jumping over last time, and we do have implied seek turned on. So that's a thing. Because I don't really know where this is hanging, if it is hanging. But yeah, that looks fine. Seek command. Drive 0 head 0. Wait for an interrupt. Send a sense interrupt. Then we set up our buffers for the sector transfer. Send our sector transfer command setup words, and then we enter our loops and read our result data and whatnot. So probably for some reason it's hanging inside of one of these sector byte loop things, but let's go back and look to see if it is still hanging. No. Interesting. Lala says, hi, I'm finally able to catch you live again. Yeah, I know. I'm all over the place with my timing, and I know some times are better than others, so it's good to know that some people are able to make it. Okay, so the question now is, theoretically this filled up the whole, if it finished. Hey, Dirt Piper! Yeah, earlier in the day seems to be good for a whole sector of people. Right, so it should have... The only way we could have gotten here is by getting higher mesh from India, by getting through both of the sector byte loops, which means we filled memory with 512 bytes of probably garbage. I remember them being garbage last time, but let's give it a look. 200... Well, now I'm pissed. 0200. Oh, sorry. 0201. Well, I didn't do a single goddamn thing. 0202. 0203. 0204. I'm just gonna dump a bunch and 0205, and we will compare 0206, 0207, 0208. Okay. So I'm pretty sure EB is in fact the first byte on that sector. Yep, I wonder if it's just error correcting bullshit. I wonder if last time we got garbage because the disk is unreliable and so on and so forth, because that is totally a thing. But let's see, disk1.hex. Yep, that looks pretty much perfect. EB. Oh, sorry. EB. EB. Oh. Damn you. My key combo's always screwing up stuff. Here, let's just grab the first chunk of bytes. It looks pretty much perfect, though, so. Copy. So, yeah, I guess this goes into Wereworm's. Inadvertently, it goes into Wereworm's suggestion of check check your registers and status and whatnot for error stuff, because that's probably what was happening last time. And we just need to retry. It is apparently just that easy. But let's really check. Let's just really check. Okay. EB28, EB28, 90, 90, 2939, 2939. 00. That's supposed to be a 4-5. And then 213F. Okay, so yeah, I think, let's see, how many bytes is that? EB28902939. 1, 2, 3, 4, 5. Interesting. So I wonder what is in my Wonder Ball. I wonder if we are overflowing or underflowing or something. You know what I realized too, that we might want to do that can almost certainly help us with our potential racing against the floppy and trying not to lose bytes thing here. It could also just be that it was a shit read. Though there should also be a way to check the CRC. So there isn't much I need to check here. And we should have stashed the result bytes somewhere, so that is potentially something. Oh, Dirt Piper said you read from 2025 instead of 0205. Well, that'll do it. Really? Really? Wow, you are so right. Oh my god, whatever that character is, I can never make it out. I think it's right. Oh, it's D, 2D. Which is correct. So, okay, maybe this is absolutely fine. Which would be dope. Which would be very, 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 very dope, y'all. Yeah, so the 02, bleh. 0205. You do. Wow, look, it's a 45. 1 second, I have an alarm going off. Yep, that is reminding me about an eBay listing. Thank you, phone. Thank you, Dirt Piper, for correcting my dumbness. Okay, well, I think we can read a sector. Here's the thing to do. Let's see. Let's read. Ooh, let's read. You know what would be fun? Is the. Oh, of course, that one's going to be easy. 03FF. Or let's do 03FE. And that should be AA. Ah, okay, so we did take a shit somewhere. Which is fine. I would have expected that. And that's probably why this took so long to finish, too. 03FF. Yeah. So the question is, when did that start? Because I was hoping we would see the AA55 from the, like the boot signature. But we don't. So, let's look at 0300. Let's look at 0280. Let's look at 0240. Let's look at 0210. Okay, let's look at 0220. 0228. 0226. 0223. 0221. 0222. And then 0223. I think I just typed that in wrong. 0223. Alright, let me just check again. 0222. Okay, so it looks like it lost the plot somewhere between 0223 and 0222. I mean, somewhere between, right between them. Wareham says, you should fix the ordinal xdump command would speed up the verification. Let's check really quick, because I think I'm putting in more than I need to. Let's see. 0200, set the address, and I think, yeah, it does. It auto increments. Cool. I thought it did that, but I haven't been using it, so yeah, that's gonna be much better. And you said that the dump X command, but I think this is just as good. Though of course that I don't think that's broken at this point. I think that is actually working fine. It just, did I unbreak it? Let's find out. I don't remember at this point. Let's do 0200, set the address X. Oh yeah, no, interesting. Like the address is totally off still. Fascinating. Anyway, at least I can always do 0200, set the address. Oh yeah, Dirt Piper, we have a monitor and everything. It's a real crab monitor. That's no offense to the person who made it. It's just for our purposes. Not amazing. But we can just do this. All day. All day. We don't get addresses, but that's not really that big of a deal. So, yeah, next thing. Let's look up how to detect an over or underflow, because that's going to be important. And what I was thinking, actually, before I even do that, I had a thought the other day that, you know what we should do is some more loop unrolling, because Wareham says it's not a crap monitor, it's a minimal one, and that is very true. That is very true. And it was a more decent monitor until I started messing with it too, so to be fair, that's my fault. But yeah, I was thinking, what if, and now this is going to be the question of, do I gain more than I lose by doing this? Is unroll this loop a little bit and always like just have it read 8 bytes at a go, because that should be super fast as opposed to the whole loop of going through the loop every time and checking the increment and everything. Is maybe if I just wham do 8 and then like I could just even increment by 8. That should be good and fast enough. And I think that might, if we're having over underflow issues. Anyway, what I will do is I'm just going to play with this really quick and see if it improves the reading. And then let's take this and let's write an actual error-checked floppy read sector command that we can build other stuff on top of. Because I think Wereworm has been patient enough with me that they deserve some good code at this point, or better code. But yeah, let's try doing that, because that would just be... And do I even want to do the JSR here? Because that's going to take time. That in and of itself is going to take a while. I mean, not a while, but it's going to be extra for jumping and jumping back and putting shit on the stack, and I might just unroll that a couple times. 8 times. Let's just do that and see how fast it gets. Or... Yeah, I'm just gonna unroll. And that would go somewhere around here. Yes, right here. So instead of doing the JSR, which I realize is kind of silly because I went to all this trouble of making this a subroutine, but whatever. Let's just call this read 0, read 1, read 1, and I guess we need the increment y anyway because we're using it for indexing. So, oh, actually, you know what would be probably faster? How should we do that? What do you think will be fastest? Should I go with using the indexing? Or should I just increment the low buffer address? No, that's crazy. I was going to say increment the low buffer address and then only at the end of my 8-byte mega read, update the whole thing and see if it needs a rollover. Oh wait, it will never need a rollover. Right, like by definition, because duh. Well, I'm just going to start with, we're going to stick to the indexing, which I don't know if that's going to be cycle-wise slower or faster than, whatchamacallit, slower or faster than why it's early in the day. Why is my brain escaping me? Slower or faster than just, I don't know if the indexing will be slower or faster than going out to 0 page, updating a value in 0 page, doing all that, but it may be faster doing it that way. Fewer cycles, I mean. Anyway, let's just keep on rolling. And do 8 of these old boys. 2. 3. 4. 5. 6. 7. And 8. And then finally, check to see if we need to continue this loop. And I'm gonna copy all this. Replace all of these with high buffer address. Replace all these with, I'm just going to put a B on them. I can already think as I'm doing this that there are even more betterer ways to go, but I'm brute forcing this one right now. Okay, and then let's make sure, I'm just gonna blow all this shit out. Oh, and if yes, the NES is still running, so before I do this, I should check those status registers too, because those are saved in a place. Yeah, I set aside locations for all those. But that should be on rolled. Let me just make sure that I didn't fat finger anything. Read 8B, read 7B, read 6B, read 5B, 4B, 3B. Yep, I sure did. Read 2B. Read 1B. Okay. Yep, Eric pointed it out. Forgot to rename some labels in the jump 1B, 2B, etc. Yup. Thank you guys. Had I not caught it, you would have had my back. You would have saved my bacon. Okay, like I said, before we go ahead and just burn that, which probably won't help anything, because it will probably be marginally faster, if at all. Let us check the 0-page addresses for these results. So, they start at 14. So let me just dump-a-rooney those guys. So, let's clear the screen a little bit. And 0014, set the address and dump. Huh. Actually, I guess that shouldn't be surprising. Ooh, what did I say? I said it stopped at 2022, I think. Let's see. 0222? Yes? Is that right? Yeah. And 02, I wasn't even thinking about this. 02 is the value for... it's the value... It's like a sentinel value almost at the end of the status stuff. So let's back up a few. How many status things do we have? I think 7. Let me see. I can tell you by looking over here at the code. Excuse me. 1, 2, 3, 4, 5. Yeah, 7. So that's going to be... math. I'm definitely not over here doing it on the calculator. That would be embarrassing. 0x222 minus 7 is 539, which 539 is calculator. 539, yes, 539. 539. That would be 21B, and I'm just coming up with that off the top of my head. We need to dump from 21B. Yeah. Okay. All right. Okay. So let's go to 21B. Let's start at 21B here. 021B, and I'll make sure I'm not off by 1. The classic. 1, 2, 3, 4, 5, 6, 7. I was off by 1. So we should start looking at that 40. Alright, so this is supposed to tell us the status on everything. And I've already forgotten the status on these, but I will jot these down and switch back to the other screen, and we will reread that together. Please hold. I'm sure it's just telling us that there was a underflow issue, but I'm curious. I gotta read the documentation to see how it indicates that there's an overflow. Good morning, Taco Man. Yeah, this is a good weekend day. Everybody's popping in. And Cliff Cheney. Whole crowd. Okay, so sorry. So it's 40, 10, 01, 02. Let's research. So, status bytes, you say. STO. I feel like I found the status bytes more useful in here. Let's look in here. STO, STO, STO. Oh, right. They're not here. They're written elsewhere. Status register 0? Yeah, there we go. Next, please. Next, please. Next, please. Next, please. Next, please. Where's the actual section on status registers? We have looked at this. I want the bit fields. Here we go. Okay, so let's break these down in binary. So this is 0100, 0000, and then this is 0001, 000, and that is oh, 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 1, and 2 is the sentinel value, but I will write it down anyway. So, ST0, interrupt code 01, abnormal termination. Yeah, I thought we had seen that before, and that's the same thing that we got when we were off by a cylinder. Started but not successfully completed. So, STO abnormal termination. I don't know why I'm writing this down. I'm not going to need this for later. And then the rest is all current head address and current selected driver 00. Those are the only ones that I would really care about. And equipment check is 0. Okay, status register 1 is telling me, let's see, so that is bit 4, overrun, underrun. Wow, of course it is. Become set, blah, blah, blah. Okay, well, this surprises no one. Underrun. Very good. And then the rest, I think, are not that interesting anyway. The rest of these are, yeah, I mean, it's telling us we have an underrun. That's, yeah. Duh. But at least we've confirmed it. So actually what I'd like to do is, let me just, I'm going to burn this code just for fun. It's going to be, I don't want my code to be this fat. There's got to be a way to trim it up, but I am curious. I already expanded it, so why not? Let's just burn it and see what happens. Nope. Yeah, because I think the reason it takes so long to get to the prompt is probably that it reads those first couple bytes, overflows, and then we're sitting there reading error status for a while. And if we just let me even look before I get over there, because I bet there is a flag in the MSR or something that tells you, hey, there was an error, and then you check the status to see, oh, what was the error? Okay, yes, this is what I care about. If MDMA equals 1, loop back to the beginning of the outer loop unless your data buffer ran out. Detect underflow, overflow. So, what does NDMA tell us? I know we've looked at this before, but what does it actually say? NDMA and busy are also useful in pulling PIO mode. NDMA signals the end of the execution phase of a command and the beginning of a result phase. Aha! Okay, so is it going to slow us down a whole bunch more to always check that, and if that happened to be high, you know, bail out to a there was an error section? We'll just have to see. We'll just have to see. Because if I'll do it this way, we'll see if this unrolling is even fast enough to keep up with this. Because if that's not, then we're definitely going to have to knock down to double data rate, which is fine. That's totally fine. But this will tell us. If we can't keep up with this drive with a largely unrolled loop like this, then there's no hope. Then we'll knock down double data rate. Then we will almost certainly be able to actually write code that can check. Did we underflow, overflow, and bail out? Anyway, that built. Let's program it. Let's do it. Let's go for it. Wareham said underrun means you read too fast. I think I just... It must be that we got it, like, that we're understanding that backwards, because there's no way I can read it too fast. You think I'm reading it too fast? That would be interesting. I mean, that, yeah, I don't know. Because I'm sitting there waiting for the RQM bit. An RQM bit shouldn't go high until I have data in the FIFO. Yeah, Wareham said it could be you're supposed to check if there is data in the FIFO before reading. I'm pretty sure. That's what I think the check on the RQM bit is for. Which I am doing. That's what, just to be clear. Read FDC. What was I calling those? Let's look for 1B. There we go. Yeah, so it's that load A6804 is reading the master status register and then checking to see if those bits are, set to I have something available for you to read. So unless I'm totally misunderstanding something about how that works when you're doing a big transfer like this, which is totally possible, I think it must just mean that overrun and underrun are backwards from our perspective as far as the way that they're describing it. Count the cycles. Yes, but no. Only because my brain can't keep up with counting cycles. And that's a me problem. Okay, loaded. Proged. Backed. Okay, let's see. Especially if this gets to the prompt any faster. I bet it will. There are two possibilities. Either it will be exactly the same or it will be different. A lot of people don't realize that. You got two cases there. That was faster. That was significantly faster. I guess let's try and work... yeah, let's start at 03FF again. Let's see what we got there. FF. Okay. So we probably managed to go a little bit longer before having an issue. Let's check 0222. Oh, interesting. Maybe it has failed even more. 0220? 0200? So did it fail before it managed to do anything? Let's check the... Where am I keeping the version flag? Did it totally just fail initialization? That's always a possibility. This is why you should retry and retry and retry again, which we are not doing. Yeah, where am I keeping version? 0C, that is right. OC. Okay, so it got past the version command, for sure. What happens after the version command? We do the version command. Where even is it? Version. I mean, this isn't really quite worth it. I should just restart this thing again really quick. Yeah, version, then we start the motor. Then we recalibrate. Okay. Then we seek. Then we do the read. So it's probably seeking or something that took a crap. So let's just redo it since we don't have any retry code or error checking code. I'm sure it just pooped itself for a second. Wareham said, also, I think your motor spin up wait is probably not a 500 millisecond wait. You are probably right about that. I would agree. But the motor's already spinning, so it shouldn't really matter. The motor spins from... Yeah. Oh, that was even weirder faster. 1 second. 200. Huh. Fascinating, Captain. Oh, 200. Okay. If this does exactly the same thing several times in a row, then it's a code problem. Now it's 80. Cool. Okay. We're getting somewhere. Okay, one more time for good measure. And then let's start applying actual checks to these commands to check the status and keep redoing. Let's clean these all up. Because clearly, you know what's going on is that we're not retrying anything, and when it is marginal, it doesn't work. It is interesting that it just fails every single time now, though. Make sure there's not anything obviously dumb in code. Read 1. Reads to low buffer address. I mean, that looks fine, right? Right? Just trying to see if there's any reason that this would exit early. You know what I mean? So you'd think it would at least read the first little bit here before totally taking the crap, and yet we have nothing at 0200. So, yeah. All right, let's start cleaning it up. Let's clean it up. Let's put in error checking. Let's be thorough. All right, so what do they say? Wareham said, theoretically, would there be a way to use interrupt mode? Well, it is, so there's not interrupt mode, it's always sending interrupts, and also it sets a flag in a register when an interrupt happens, so you can check it either way. So that's the only difference, really, between hooking up the interrupt signal and just polling it, is just that. There's nothing besides that, and I don't think it would make us significantly faster since we're polling anyway. If we were in a multitasking environment, then that might be more useful, but we're sitting there just waiting for the IRQ bit in the register to go high. So technically, we should be able to connect up the interrupt line to the NES's interrupt line and get interrupts, but I don't know that it would be that useful. The real thing is we would want DMA. DMA is the thing that would make this, you know, work at a good speed. So, what is the recommended thing for stuff? I think usually really what they say is if you detect a bad condition, reset the floppy controller and go again. So that might be the way to go. But where's the first place that we can really check that? It's like specify for a bunch of these, like this doesn't return any information, this doesn't return any information, this doesn't return any information. I mean, it returns information, but like it doesn't say, hey, I failed or not. Seek will give you some information. Here, let's increase this weight while we're at it. Just because. Recalibrate doesn't, well, it sends us status registers in the sense interrupt command results. So that might be the first thing that we can check. And you know what? Let's go ahead and yeah. Let's just make this a nice tasty loop. And let's make it the kind of loop where at the very end of it, there's a couple things we should do, because at the very end of it, we should check the track 0 pin and keep spinning until track 0 is at track 0, and then have a timeout value. Yeah, let's actually break these up. So, I guess we can use here. Here's what I'm gonna do: is I'm gonna top down this thing. Let's read a sector, and we're just going to make this out of stuff. So we're going to make it out of all calls, and then we'll implement the calls. So JSR init FDC will be a thing, and then let's see. I guess we'll have a JSR like turn on the motor. Trying to think of all the steps we need to break this up into, because when we break it up into steps and subroutines, it makes it a little bit easier for us to like say, did that subroutine complete okay? If not, retry a few times. It'll just make that easier to write. So we should definitely, like, seek should be a subroutine. Read a sector should be a subroutine. So maybe we just do that. Is maybe like select drive and deselect drive. Yeah, so let's have an init floppy controller, and then maybe a what did it even just say? Select drive? To like select it, turn the motor on, all that stuff. Then JSR. We don't really need the seek, but I'm still gonna add it. And I would think we would want to put select drive. I'm not gonna have any arguments, because what arguments are you gonna have to select drive? We're always we have drive 0. That's the only drive we have. That's the only drive I ever plan on supporting. So, but for this one, I will load a 0, and we'll seek to whatever's in A, and then we'll probably, this is where we would do error checking and return something, but I'll do that in a second. And then I guess it would just be JSR read sector. And I guess, there's a fun one. Should we just, because in a lot of 6502 systems, arguments are passed, like, not on the stack or anything. They just, like, set up a block of shit in memory and then pass the address of that stuff, or pass that address in a 0 page. So, Worm said, I really love your streams because your approach to things is so much different from what I would do, and I love it and hate it. It's so fascinating. Can't look away. I'm glad to be your train wreck. Yeah, so anyway, for read sector, I'm trying to think if I just want to... Do I want to pass in the head as well. I mean, I guess here's what I can do. Here's the thought. Is we could... Because I don't know that I really need or want the seek drive command, seeing as we have implied seeks on. Anyway. But what I'm going to do is maybe sector number in A, and then we can do like cylinder number in X, head number in Y. That should be good, right? I think that'll work. And then again, we'll have read sector just return a success value. I guess in A would be fine. And I guess we can just keep redoing this whole loop until such a time as we like time out or whatnot. But let's build on this and start taking the code we already have and implementing stuff on top of it. So init FDC should be everything from here, which toggles, let's see, which supposedly, oh, right, my hardware reset. Well, we'll just do the hardware reset once at the top. This guy. Whatever. I'm going to increase this too, just because why not? Probably not necessary, but yeah, we'll just start from software reset. So, well, let's call this. What am I calling this? Init FDC. And is there anything that can fail in here? I don't think so. I think we just do it, and we will re-init if we detect any other commands fail. Is my thought. Wait IRQ, blue. Send some sense interrupt commands, fine, whatever. Actually, that's probably something that we should just, in and of itself, turn into its own routine. JSR FDC sense interrupt, and we will just move this down somewhere down here, somewhere. Way down, all the way down, way down here, way down here, down here, way down, down, way down here, way down here, way down here. What was I calling this? FDC sense interrupt. Cool, that's a subroutine now. Done. We'll replace those elsewhere, but that's a subroutine. And I also kind of want to update these to have like a timeout to read and wait for RQM several times, and then if it just gets too damn high, then we bail. We'll see if that... I'm worried about that making things way too slow, but we should probably do that. Probably. But that's adding a lot of frickin' commands is the thing. Arm says he would want the explicit seek only for formatting and reading beyond track 79. Wolf said you're going to take up whole memory with the floppy driver. Damn straight I am. Okay, anyway. I will get back to those. I don't want to do it right now. Not because it is difficult, but because it is frustrating to me how many cycles that's going to add if I want to do the proper check for timeout and whatnot. Anyway. So back we are. So now we just jump to sense interrupt and loop that away. I think the configure command I'll just keep literal because I'm not going to use it anywhere else. And the set data rate and the specify command. We don't really need to do the version command. That doesn't help us at all. And then we get to the point where we are seeking and whatnot. So this is the end of the initfdc command. Cool, that's it, done. Then we have select drive, which I'm just making a thing because that'll... I also want to make like a deselect drive to turn the motor off and all of that good stuff. But this will also be if anytime we want to select the drive, turn on the motor, wait for the motor, all of that stuff. We'll call a subroutine. So, what the hell did I call that? Select drive. I should really probably preface this all with FDC. Keep it clean. Keep it clean. FDC init, FDC select drive, FDC seek drive, FDC read sector. And then, and I think Werewolm will also appreciate this, is I'm figuring once I take this routine and slap it into its own loop, we can on each loop say, throw some text on the screen that says, I'm reading the floppy, and I failed or I succeeded, trying again, so on and so forth. Because that's going to be... Werewolm has been asking me to do some frickin' debugging output for ages. Right, so we got our... And I guess here we could do our... jump... init. There we go. And I'll remove the jump init down here. I know I jump all the way around the place like wild. It's because that's the way my brain works. I'm sorry. That's just the way it is. Okay, so the next thing we were doing was that floppy motor start command, right? Or subroutine, rather. FDC just select drive, so that's as easy as set those bits, do some spin, return to caller. And then this becomes... Oh yeah, so this is a thing. Oh, you know what I'll do? So I was trying to figure out, like, recalibration happen, like, during startup, right? It should. But, yeah, what I'm going to want to do, I think, is... Ooh, yeah, let's do this. Send the specify command, do. But here, let's do jump subroutine, FDC, recalibrate. We'll make this its own whole thing. And FDC recalibrate. And in here, let's then do a JSR FDC select. Was that what I was calling it? FDC select drive. So we'll select the drive, turn it on, blobbity blobbity blah whenever we do a recalibrate. And let's see. And here's where we want to do the loop-de-loop-de-loop. So this is really the first place we're going to do like a validation and check and exit loop. I guess let's do load X with we'll do a countdown. Literal, I don't know how many times should we try doing this? Let's just do 16. We should never ever get that high unless the hardware is super effing broken. And let me keep in mind too, because I've made many of these errors before in the past, I need to make sure that I remember the state of all of my registers, because I am prone to screwing that up. Yeah. Anyway, so recalibrate loop. And that's where we send the command, wait for the IRQ, sense interrupt, doodly doodly do, and then check to see if we're at track 0. And that requires looking in the documentation. I believe that is in the digital input register. Or is it the digital output register? They're kind of backwards on things. Digital input register, let's check. Digital input register. Digital input. DIR? Okay, thanks for nothing. Digital input register. Digital input register. Digital input register. Here we go. PS2 mode. This is not the one. I guess it was the digital output register. Really? These registers, man, I'm telling you, their names suck. No, not this one either. What? Okay, which one had the stupid track 0 flag? TRK0, status register A. Okay, whatever. So status register A, check bit 4. And status register A is the one at 000. Easy as pie. Load A. 68. That's where I put it, right? Uh-oh. I don't remember anymore. Yeah, 6800 is my base for those. So load A and then mask it. And with a literal, I said bit 4, right? So that is, just making sure that was 0 index the way I expect it to be. Status register A, come on back, please. Okay, and it's inverted, which is fun. So I want, yes. So that will be 10 and 10, and then we want it to be 0. So branch if it is not 0 to recalibrate loop. And then up at recalibrate loop, let's just do this right at the top of the loop. Decrease X and branch if it is 0 to recalibrate failed. And then we do not want to do the seek. Okay, so at the end of this, we read the status register, check that bit if it is, and if the whole thing's not 0, we try the recalibrate loop again. Otherwise, let's put recalibrate failed here. And I guess, let's see. Let's do load A. What will we use for our error status? What makes logical sense? So this would be if it succeeded. I'm gonna go with 0 for success. Let's do 0 for success, and then numbered things for error codes in a Unixy type fashion. So let's load A00 and then return here if we succeeded. And then if it failed, then we load A. Let's do 1 and return. And that is our recalibrate command, except that we have not yet implemented select drive. And let us see. Did I destroy that code? That would be pretty funny, wouldn't it? No, it's right here. Oh, okay. No, it was implemented. Sick. And the rest of our code, let's see. There's a floppy seek somewhere in the middle of this that I guess we'll have to move around, but FDC read sector will start there. And I guess, let me get that. Where is my seek code? Seek. Right here. FDC seek drive. Cool. And perhaps I should also have an FDC deselect drive. Maybe. I don't know. We never really wanted, there's no need for us to deselect this drive, but we are going to be redundantly selecting this drive a couple times, so that's a thing. Of course, usually I think when you're running a floppy driver like this, you usually keep a flag somewhere that says, has the motor been on all this time? If so, don't worry about turning it back on again. Wareham said the debugging output was just a suggestion to help find where things got stuck, but you've already read something successfully, so who cares? And also, it's the retry countdown. Alright, I feel like there are probably many ways in which this code is screwed up, but that's not going to stop me from keeping working on it. Okay, so now we have to do this error checking crap. Yeah, I guess. So FDC select drive, that's fine. FDC seek drive. I don't think I need to do. Let's just get rid of that. Let's just get rid of that for now. And then now we can go straight to FDC read sector. Right? Yes? Didn't I rename you? That should concern me more than it does. Anyway. So yes, let's flesh this out. Oh yeah, because I was sending that failure code, but I'm not really doing anything with it. So where was I sending that? Right, at recalibrate failed. So that is called from the init command. Yeah, we call FDC recalibrate right here. And let's do. Well, actually, we're gonna have that status. It's the last thing we do in the floppy drive setup. So the A will contain whether things generally succeeded or not. So we automatically magically get that. So let's we can just do I don't know if returning from a subroutine is going to screw up my flags. So I'm just going to do the lazy old compare with 00 command, and then finally branch if it is not equal to 0, which is kind of funny. Because anyway, let's make a FDC success, FDC, what to call this? FDC init failure. And Eventually I'm gonna wanna, I'm just gonna put these labels here, but eventually I'm gonna wanna put some like nice init failed and so on and so forth codes there. Or, you know, text for the screens. Read a sector. Cool. All right. So that would be FDC init failure, and we will deal with that later. Make it more descriptive. Subsequently, so that initializes the drive, and if it didn't work, then we failed. And then we will select the drive, which has no way of failing, or at least I don't think it's worth checking. And then finally we're going to do our sector read, which now will actually involve us having to do some work on this. But let us preemptively, I'll do the same thing where compare 00 and BNE FDC. Oh, we should do a countdown for this one too. So let's load X. Let's do this as a countdown. How many times do we want to try this? I don't know. We pretty much know it's going to fail, so let me just put in 2 here just to keep it low for the moment. I'm just going to call this read a attempt read sector, and let me do it the exact way I did that other loop. So decrease X and branch if it is 0 to read sector fail. I guess FDC read sector fail. FDC read sector fail. We will deal with you later. And so at the end of this, compare 00. And I mean, I guess this is kind of redundant. Like, we'll need to jump into the thing no matter which one we do. So compare 00. And branch if it is not 00 back up to attempt read sector, which will reset the floppy drive, start the whole attempt over again. Well, it'll decrease X, see if we ran out of tries, and jump to the failure if not. But otherwise, if this fails, it will try that loop again. But if it did not fail, then we succeeded and we can enter the monitor. So jump in it, which is where the monitor is. And now for both of these, well, it'll just be the same thing. We'll do something, and then we want to enter the monitor either way. So jump in it and jump in it. And now I have to remember how we print strings, because we haven't done that in a while. Let's put some strings at the top of this thing for starters. Let's call this something. FDC sector read attempt message. Sure. And I think, how did this work? Was I able to just do ASCII Z and write a string? I think so. What will we put here? I guess attempting to read a sector. There's my slash. And hopefully C-style escape strings are supported in there. Sector read attempt message, FDC init fail message. Actually, let's make this pretty. We won't put a new line after those ones, we'll put a new line after the result messages. FDC, I guess read fail message. Failed to read sector. And you know what? Let's even do an FDC read success message. Let's give ourselves some hope. ASCII Z. Red sector. Yay! Now, let's print these. And I believe to print these we jammed the high and low value of the address into string pointer. Yes, we did. But now I also have to remember the syntax in this assembler for picking out the high and low parts of those messages. Oh my goodness, we are getting a lot of code. We're going to need to also start splitting this up. Okay, where was this thing? Here we go. So let's start by I guess, yeah, load A, however the heck this worked, because yeah, what was it called? Sector read attempt message. What is this? Okay, let's just look this up. CA65. CA65 address low part. Maybe expression evaluation? No. Oh, here we go. Alright, so it's the less than and greater than symbols. And hopefully I can use them right. I think I put them before this. And then I store A. Oh, and the fun thing is I need to make sure that my subroutines don't screw up my counters and shit. That's fun. That's gonna be fun. Anyway, and I wanted to add retry to the floppy wait for data and write command stuff too, so yeah. Anyway, store that in string pointer, I think. Wait, no, I want to put the low part and then the high part. Load A, the high part. Wait, right? Oh no, I was right in the first place. Low part, then high part. Sector read attempt message. Store A in string pointer +1. And then JSR print string? Print? Was it just print? We're gonna find out. We sure are. And then same shit all over here, except we change the message. This is another thing. Probably could macroize this pretty well, but whatever. FDC read fail message. FDC read fail message. And here again. FDC init fail message. FDC init fail message. Oh, and I also think I want to put literals in front of these, because otherwise it may try and use them as a zero-page address, and that would not be correct. And final message I think I need to do in here is the success message, if I can be so bold. And that goes here. FDC read success message. Yes, there we are. FDC read success message. Nope. And I know the print routine is definitely gonna fuck up my my X register, so that's fun. Should I just put that in a zero-page address? Probably. Or I can push it at the top of the loop, is an option. And I guess actually really this should go before everything, even that message. So what we can do is I guess we can just load A and pull A, transfer A to X, decrease it, and then do the check, and otherwise push it, or transfer it back into A, I suppose would be good. Transfer X into A, then push it. Okay, so that should get around that, and I think that's the only thing I'm keeping track of in here. So that feels okay, maybe. Okay, I think that's like that bulk of this. Now I just have to fix up everything that it references. In the meantime, let's read some chat. Where said, call it general failure reading drive to give as little information as possible, as is tradition. I think I'm already giving myself plenty little information with these, if I do say so myself. All right, so I just know I'm going to build this, and I'm going to have like, I'm going to be stomping over register content and whatnot. It's just going to happen, and I'll deal with it as it comes. But the next things that I need to do are, I guess, on the we'll add retry countdowns to the read and write FIFO subroutines. Oh wait, also, because I'm slightly worried that this will unbalance my stack, and I need to think about that, because in this case it will jump all the way to the end, but I think that's okay. I don't think that's going to unbalance my stack. We'll find out. Or if it does, I don't give a fuck. Hopefully it won't break me too bad. Let's just keep on busting ahead. So what's the command we're looking for? Oh, also the fun thing is that these, yeah, let me actually, I'm gonna undo this foolishness. Not that it's foolishness. It wasn't a terrible idea. But I am going to have these call into the subs, and I'm just gonna do it 8 times in a row before doing the old loop. It would be funny if it was underflow that whole time, and I was reading too fast, man. But I find that highly suspect if that is the case. So we keep that, and let's see. I guess it's just JSR FDC read. What was it called? Read FDC data. Now this was pretty much it, right? Yeah. And actually, you know what I'm gonna do is I'm gonna put this right back to the way it was before, after all of that stupid work, and it'll fail, but then we can get it to a spot where it kind of works, we get failure messages, and we know what's going on, and then we can try and tighten it up from there. And I think I will also initialize a Git repo right after I'm done writing this version of the code, because there have been way too many times that I've needed to go back to an older version of the code to restore functionality to exactly the way it was before, and it didn't quite work the same way. And it would be probably a good idea to just have this in a repo, literally just so I have history, you know? Okay, so that's restored to the way it was. I will come back to you because there's more work that I need to do there. Yes, so send FDC command. So really what we need to do here is here. Let's save everything. Push A, then transfer X to A, then push A again, and then at the very end. Oh, right, this was the whole thing. Because we are pushing A because we want to save A because we want to store it in the whole thing. But I need something for a counter, and I don't want to screw up my calling code. So, I guess what we can do here is right before we exit, pull A to get the X value, then transfer A to X, then pull A to get the A value, write it, and return. That seems fine to me. But we need the failure mode, so now that we have done this, let us load X. I don't know, how many times do we want to retry this? 10? 5? 6? Let's do 10. I'm going to go with 10. And we'll use our same old classic. Actually, that seems kind of low. Because this is going to be just like actively reading this register, so it's going to be pretty fast. So let's bump it up to, I'm going to go as high as 80. That might be insane, but it might not be. And we'll follow that same pattern that we did before, where I'll just decrease X, and if it has hit 0, then send FDC command fail. Otherwise, we just proceed on, and that's that. And for send FDC command fail, now we need to still restore the stack, so we will pull A again. Oh, so this one is interesting because, well, I guess here we can return a value in A because we don't care about, we care about getting what they passed in for A and putting it into the register, but after that we don't care about maintaining it. So let's, in both of these cases, let's see, so here we'll follow our thing of 0, 0 indicates success, and then here we'll make sure the stack is balanced. We'll restore X, restore A. Well, we'll pull A off the stack so that it's not unbalanced, and then we'll just load A with the fail value, and then RTS. There we go. So, I worry about this being slow as a motherfucker. But it's the right way to do it. And then, same thing for read FDC data. I'm also going to do, let's call this read FDC data loop. And same thing, we'll do setup here where I will, and this one we're returning a value in A, so that's a little annoying. I mean, so I can just use another register to indicate status, which is annoying, but I guess that's what I'll just do, because the alternative is that I put the result value in a different register, and that feels almost worse. So let us go ahead and do that setup. Push, or no, transfer X into A, and then push that value. And now that I've got that backed up, load X with same number of retries. Let's do 80. And at the top of the thing, do a decrement X, and if it zeroes out, read FDC data fail. Good stuff. Read FDC data fail. I'll go back to you. And here we need to make sure our stack is balanced. So before we return, pull A and transfer A into X to make sure that the user's X value is safe. And then we will need to do that here as well. Pull A, or actually, no, yeah. Pull A, transfer A into X, and RTS, and then I think the only thing left to do is to set the return value. You know what? I guess if we don't have to do this part if we define that we're going to return the status in X. So I'm just going to do that. And then we know X will be dirty. So instead of transferring A to X, load X with, let's see, this is the success case, so 0, 0, and in this one, load X with failure value, and don't do anything with A. Okay, I think that's those. I think that's something done with them. So now the fun thing is anything that calls those. Ooh, okay, this makes everything a little more annoying. Not a ton more annoying, but a little more annoying, because any one of these could fail for some weird reason, right? For any reason, things could go sideways, and we could not be able to read data from the FIFO, right? It just times out and takes crap. Which means every time we call them, we might potentially need to bail out on the whole thing. I think I'm not going to do that everywhere, because the only, I think I will only do that in the read sector code, I think. Because if read sector fails, then we just reset the whole goddamn thing and try again. And that makes the most sense to me. Because if you know, something went sideways in the setup, then by the time we get to reading the floppy, it will be screwed up and it will reset. There is a possibility therein of... Actually, no, there's not. I was going to say there's a possibility of hangs because of that, because of the FDC getting in a weird state. But no, actually, because we've put timeouts in the check the FIFO for a value and put a value into the FIFO commands, those will always eventually exit when they time out. So if things get way sideways, then those will just time out until we get to the floppy sector read thing. Then it'll time out or get a bad value and reset. So yeah, that should be fine. So yeah, let's just update this, I guess. We just need to make sure we take our arguments and do something with them. Actually, I'm going to start with just screw the arguments. We don't need the arguments right now. We're just going to try and read the one sector. And then we will add arguments as they become useful, because we've already made a lot of code changes. So this will just always try and read sector 0. Okay. So now let's read that code. Read sector. All right, here we go. So we set up the target address, which really no reason to do that every single time we do this, but whatever. Then read a sector maybe. And here, I think, is where we start doing our check. So it's a pain in the ass, but, and again, a spot where macros would be useful. I guess transfer X to A, and let's check really quick if transfer X to A sets flags, because that would be useful. 6502 instruction set, if you would. TXA. TXA, it sets the negative and 0 flags. Perfect for me. So actually, for send FTC command, we were putting an A, right? It was just for read that we were putting an X. Yes. So actually, we just need to do compare with 0, which is probably not necessary, and because it probably still has the flag set from when we returned. Anyway, and branch if it is not 0, not equal to 0. This is why this one is confusing. Because now I'm all of a sudden using this backwards because of the compare. But anyway, and yes, let's call it, I don't know, FDC read kind of unfortunate that I already used that label, huh? Maybe let's go back and rename this one. FDC read sector fail. FDC read sector fail, read sector fail, read sector fail, read sector fail. I'm just going to remove the FDC from the beginning of these. Actually, this one probably fine. Read sector fail, that's fine. And read sector fail. And okay, cool. So, as we were, FDC read sector. So I pretty much just have to do this for every single one of these, which is fine. Oh my goodness, excuse me. There. Doop. 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 Okay, and boop. Except this will be even adding more steps. Transfer X to A. Oh god, that gets annoying because my value is in A. I could do fun hacks like just decrement X, and if it is non-zero after a decrement or an increment, or yeah, if it's non-zero, because if it's a 1 and you decrement it, it will be 0. If it's any other value, it will be non-zero. So that's a hack that I could use, that I might just use. Let me look at chat really quick, because I've been writing a lot of code and not reading a lot of chat. I missed a PHA before the read sector. I'll have to go check that. That might be old, but... you can prefix the label with an @ This will make it local between two real labels. Good to know. And Minor Illusion says, good morning. Good morning to you, Minor Illusion. I will go back and review some things. Let me know if I already fixed them or not. But yeah, so... Let's do that, because that's actually... That should be relatively fast. If I do... right, so if it's 0 and I increase it, it will be non-zero. If it is... Or no, I want to decrease it. So if I decrease... I guess I could check for it being negative too, right? Whatever. If it is anything... Okay, so if we assume our only return code is 1, which they are right now, our only error return code, then if we decrease it and it becomes 0, then it was an error. Right? So we decrease x and branch if it was 0 to read sector fail. Right? I think that makes sense. If x was 1, then we decrease it, it becomes 0, and if after that decrease it equaled 0, we jump to fail. Otherwise, if it was 0 and we decrease it, it's going to be FF, which is not 0, so this will not. Yeah, so I think that's nice and fast, hopefully. Man, now I actually want to make X the return status register for everything and do that, because that should be way faster. And FDC read sector fail. Ooh. And I'm going to want to do this for these two. Yadoop. 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 Nope, I was getting way too excited about putting this in. Read FTC data, 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 read FTC data. Okay. Actually shift these a little bit because I want those to be with the code that actually belongs to them. Okay, I think I'm getting close. So, I think if we get to this point, we just return with a good status. So, load the old 0, 0 for good job, you did it, and return. And then FDC read sector fail shall be load A 01 RTS. Again, if this works first try, that will be a total shocker, but we got to start somewhere. Okay, Wareworm says, I lost track. There was a load A followed by a label followed by a pull A. I feel like I may have addressed it. Let's run. Let's build this and run it and watch it fail, and then see if it was that. Oh, because I am sick of writing code now. Oh, why do I always do that? Link it, build it. Symbol print is undefined. Thank you, Visual Studio Code, for telling me that a label exists that is not there. Super cool. Then what is it called? Did we get rid of it? We might have gotten rid of the stupid print string code. That would be annoying. And again, a reason why it would be nice to roll back. Let's do that in just a second here. Yeah, I think I totes deleted it. That's great. Whelp. guess that's relatively easy to implement. That is... How does this go? Let's see. Our string is in that fixed address in the 0 page. Our string pointer is in the fixed address in the 0 page. And I think we literally just... let's go ahead and transfer x to a. Push a. Cool. Print stir loop. And all we do is load a from, or I guess we should probably set x to some kind of pointer, huh? Or some kind of value that we can increment on. Load x. Actually, I think this needs to be y, maybe. Oh, what's that? Huh. Maybe. Wait. It's going to be the 0 page indirect is what it's going to be. So fun that we wrote this before, and I've forgotten now. I think it's going to be... Oh, hey. String pointer, comma, y, actually. Let's look at memory addressing modes again. Comma y, comma y, comma, comma, comma y. Here we go. Here we go. Where is addressing modes? Addressing modes. Addressing modes. Indirect. Y. Yeah, I think that's the one we want. Cool. So instead of this, we'll use y. We will load y. We will initialize it to 0. And then we will increment y. And if it wrapped, we should probably exit branch if... Actually, branch if equals... So if this was 0, then print branch to print string done. And same thing here, we increment y. If it wrapped, then we're not going to... I don't want to print a string longer than 255 characters, because I don't want to have to deal with that, so we'll just also exit if we got to 255 characters. And finally, if none of those cases were the case, then we will call printer, which will already have the character value in A. And I guess I will do what I was doing before and push my Y value before we entered here. Even though the way I've been going, I much prefer the call-y handled stack management, but whatever, too late now. Because otherwise I would have to do a bunch of writing in the print char subroutine, and I don't feel like that right now. So let us transfer... wait. Fuck. Fuck. Always, it's like this. Okay, here. Let's transfer XA and push A back up X. And transfer A into X to back it up. Push Y, or transfer Y into A and push A, then pull A, then transfer A into Y. Yeah. I'm not a very good 6502 programmer. I can just tell by the lack of density here. Anyway. And then we just do the paranoid, clear carry, branch carry clear to printster loop. With our Y restored. Okay, and this probably should have been somewhere in there. I screwed myself up already. Let me redo a bunch of that because I think I thought line 1078 here was the print chair line, and it is not. So let me try that again. Transfer Y and A, push A, jump to that subroutine, pull A, put it back in Y, transfer Y A. Okay, all right. Oh, and after I do that push, we want to take X and put it back in A. Transfer X into A, because that's where I was temporarily stashing that. Okay. Alright. Now we do the clear carry, branch carry clear, to perkster derp, perkster derp, perkster derp. And perkster done is here. Perkster done. And here we should just restore our values and return. So we had pushed X, we had pushed Y, and that's it. So we need to pull and restore Y and pull and restore X. So pull A, transfer A to Y, pull A, transfer A to X, and return. That was the right order, right? Y then X. Y, then X. Okay, now I'm going to build. Oh wait, I should probably I need to actually reference the print string command. Oh, printster and 261 printster and 270 printster. And did I do 232 already? Yes, I did. Very good. Now let's try building this. 252 apparently I didn't replace. 252. Printster. Why did they put the Q button right next to the W button? I ask you this. I ask you this with a very serious expression on my face. Okay, 398, what we got there? Okay, that is too far of a jump. Very well. Let's just make these jumps and get it over with. Oh, wait, no. Damn it, because those are conditional branches. Damn it, damn it, damn it, damn it. Can't just do that, unfortunately. So I guess let me just give one that is closer to them. And we'll redirect to an actual, just straight up jump. And I know the stuff that people have been telling me about assembler label directive stuff is probably very relevant here, but if it is dumb and it works, then it's still dumb. But it works. Okay. And then I will just yeah, so make one that's closest to them. Jump, proceed, read, sector data to jump over this block, and this block will be FDC read sector fail A, which will just be a jump to, FDC read sector failed. There we go. Now those should be close enough to the branches that it should be fine. And proceed read sector data is here. Not pretty, but I think that will work. Well, it built. All right, before I program this dang thing, let's read some stuff. Santiago said, I dislike the C decal just because of the color's need of cleaning the stack. Yeah, I don't like having the caller have to clean the stack, because I don't know what the method is going to be screwing up with inside of it. Wareham said, I wonder when we will run into Stack Overflow issues. Probably sooner rather than later. And Santiago said, don't jinx him. No, you got to say him or it's not going to work. Yeah, Wareham said, what? Isn't jump unconditionally? Yeah, I don't know. I was high. And then Wareham just said, oh, good. Whew. All right, it's built. Let's do the old thingy. The old thingy with the stuff. Where we put the stuff on the thing. XG Pro, load it up, put it at hex 10,000, hit OK, hit program again. And again, this is, even if it works, it's guaranteed not to work because we already know that even if this ends up working just as well as our first iteration from this morning, and it manages to properly retry and do good every time, it's still gonna underflow or overflow or whatever it is actually doing. Oh god. Santiago says far jump nightmares from x86. Yeah, no. God. The 16-bit x86 addressing is just cursed. All right. Worm said if it works first try, I will be worried. Yeah, no. It better not. Oh, it's perfect. It's screaming. It's screaming for dear life. It says, it's literally saying, aye! Oh, you poor thing. Alright, so that's almost certainly because that pointer is wrong, I guess. Maybe. Okay, at least that bit we should be able to debug real quick in the emulator. We should be able to get that far. Yeah, about that. That's fine. That's fine. That I can debug in the emulator. That doesn't require any special hardware. Okay. FCEUX. Come on. It's been a while. It's been a while since we've needed you. Oh, debugger. Debugger, debug. Debug, debugger. Debuggy, debug. Excuse me. I guess we should load the ROM first. Probably a good idea. Emulation speed. Make sure it's paused. Okay. Now, I just need to figure out where the heck our actual printing code is. E1000, please. Oh, I saw something. I saw a sign, and it opened up my eyes. I saw a sign. It had some code, and I said, hey, that looks like my code. Looks just like my code. Now I have to figure out the way to do what the heck. Let's see. Let's look up entry. Entry. Okay, blue bitty blue bitty blue, initialization crap. And more crap, some more crap, more crap. FDC reset wait loop. That's fine, it's not actually like waiting for hardware, it's just toggling a random location in memory. That's cool. Attempt read sector. Okay, so I'm going to be looking for a load A2, then pull A, TAX, DEX. Let's see, load A2. Oh, is this it right here? PLA, TAX, DAX, BEQ, TXA, PHA, LDA. Yeah, that ain't right, huh? EOOO is not the correct address for that string. It is most definitely not. Or for the string pointer. Right? Right? Oh. Oh, shitballs. Damn it. You know what's up? I can just move these. What's happening is the only reason that my enter label is at E1000. Oh, wait, no. So the beginning of memory is at E1000. So actually that should be correct. Enter isn't necessarily set at E1000. It's set to whatever. It'll be with the offset of those things. So actually E1000 is the right location for that string. Regardless, let's see. Yeah, let's set a breakpoint at E1A3 right before we call print stir. E1, A3 on execute. Okie dokie doke. And go. Okay, so let's step into that call and we do some stack management. Load Y0. Okay. And this addressing might just be straight up wrong. Let's see. A is 41. I mean, actually, that seems right. Right? Like, 41 is definitely an ASCII character. What ASCII character is that? I bet it's an A. It is. So, that seems reasonable. That makes sense. Seems all good, man. Oh, wait. We were using X to store something and we didn't back it up. Shitty shits. Right, we were using X to store the temporary value in A. But wait, we moved it back, didn't we? Yeah, because A is a 41, X also has 41, which is going to get screwed up. For sure. Oh, stupid stack. Let's go to print stir. Well, watch this be the only part of the code that doesn't work properly. Right, so we put A and X to back it on up, but then we restore it here, so that shouldn't matter. Doesn't really matter if X gets hosed. And Y is 1. Anyway, let's just watch what happens. Step into the print character stuff. Wait. The hell? I don't even know where we are. Oh. Wait, okay. This is in the print character stuff. Let me actually reset this whole thing, and I'm just going to jump over the print character stuff and see what the registers and whatnot look like when we actually return from it, because that will be more damning. Oh, wait. Oh! Where had found the load A and then a pull A. Good to know. In attempt read sector. We will review that in a second. Anyway, yeah, let me reset this, and 1 second, because I think someone is coming down the stairs to ask me a question. So, hold up. Let me mute. Let me check. Be right back. Okay, I might have to call it pretty soon, because we have been going for, my god, we've been going for 2 hours and 5 minutes. Are you kidding me? Dirt Piper says, IRS tax collector appears to take all the retro computers. Huh? Okay. Resetting this thing. Anyways, reset. There's my breakpoint. Okay. Step into. Step over. There's where we load the part of the string. In Y. Okay, Y gets pushed properly. This is where we're going to jump into print character, which is probably going to screw up registers. All to heck. Oh. Probably that, huh? That place where it's pull A and then transfer Y to A when it should probably be backwards. Yeah, that's gonna do it. Yeah, and yeah. Whoops. That's almost certainly an issue. And then let's go and find Wereworm's thing there. Yeah, pull A, transfer A, Y. That'll do it. I mean, that will do something. Kill this. Just to make sure it doesn't interfere. And I'm going to run this in FCEUX again, just for fun. I want to see what it does. Like, to just let it go. Because you'd think it would time out or do something. Anyway, it's printing strings properly now, it would appear. Who knows? Whatever. Right, let us. ISS needs some 6502. I don't know what you guys are talking about. Dirt Piper says, oh, as in literally like old government offices have lots of the retro computers. Yeah, because Dirt Piper says they need them to replace their systems. That makes sense, I suppose. Anyway, all right, let's find this. So, attempt read sector. Attempt read sector. What was it? So it was LDA and then PLA. Oh, yeah. Right, why am I doing that? Why am I doing that? To stash the X value, clearly. Oh, because this should be, I guess it should be like that. That's not necessarily the best way to do things, but right, X is supposed to contain our countdown. Right, there we go. All right, let's watch this not work. I'm gonna run an FCEUX again, just after that, just again. It's not like it will indicate anything, but it sure is fast to do, so why not? I'm sure it's just going to hang again. Yeah, F it. And I feel actually very strongly that this is probably going to do the exact same thing, because yeah. It's probably just hanging somewhere silly. But look, our code is getting structure. It's getting startup messages. It's getting good. Loaded. Programming. Here we go. There we go. Pop it over. Okay. Let's see if we get a miracle. Oh, that was on. Well, now it's fully reset. There you go. Fingers crossed. Prayers said. Let us proceed. Okay. Well, there you go. Failed to... Oh, because I guess RN are not supported as escape characters, but... Okay, init failed. Interesting. Santiago says, for the next stream, you could create 2 macros, one for a function prologue, so it stores the stuff in the stack, and another for the epilogue that does the opposite, so you never run into this issue again. It would help. There's also just a lot of other dumb crap that I'm doing that messes up the stack. That wouldn't solve. Okay, so that's something. It doesn't tell me why init failed. That would have been good to know. Oh, that's my phone. It's like, does it sound like the drive is seeking? No, it's the alarm on my phone. Just for fun. Let's see if it's happens every time. Yeah, probably it does. Because it's probably failing too eagerly, if I had to guess. Yeah. Let's just do a little backtrack. I don't have a ton of time here. I think I gotta get out of here, which is a frickin' bummer. But I think this is a start of an improved framework for things that we can build off of. But let me see really quick. What could... So it goes to failed to init. Okay, so FDC init failure is our guy. And FDC init, let's see, FDC init does some stuff. So where would it fail and why would it fail? It would be good to know where it is failing. Where can you fail in it? Obviously there's a bunch of send FDC command, but those aren't having their value checked. So it was FDC recalibrate. Yes. So I wonder what's the deal here. It's probably this, right? That's actually quite interesting. Is it... Oh, I guess that's one thing we can do, is let's check that track 0 sensor, because if it's for some reason not Wareroom says next stream tomorrow. Well, next stream is, and tomorrow's Monday, so I do try and stream every weekday. So yes, and that'll be at like 8:30 is what I generally shoot for. But let's look for 6800. See what's in there. It is 96. Oakley dokley. What is 96 going to be? That is 96 is 8, 9. Okay, and then according to the Dead Sea Scrolls, let's see. Status register A. That is saying there is a pending interrupt. Okay. Drive 2 is selected. Maybe? That's weird. Step is not stepping. Track 0 is not at track 0. Interesting. Quite interesting, actually. So it's not at track 0. What? And then 0110 is head 0 selected. Index was something, and it's not asserted. Right protect not asserted, and DIR is the direction that the head is stepping. But the main thing is, yeah, track 0. That is, what? Oh, it's not at track 0. What the shit? Look at that shit. You see that? Oh, no, because, yeah. The hell? Oh, I guess that, that kind of makes sense in that I heard it reset, and then I never really looked at it, but I never heard it seek back to... Oh, Dirt Piper says, I got a job interview tomorrow. Nice. Okay, so let's actually check this, because it's not seeking back to track 0. And that seems like it should be relatively easy to figure out. Let's go to FDC, what's it called? FDC recalibrate. Which does select drive, which seems fine. The motor's on. That seems totally cool. Load X, decrease X. If it was 0, we jump to recalibrate failed. Yeah, I think that's fine. Then we prepare to send a recalibrate command. Do 07, send it. Do 00, send it. Then we wait for an IRQ, which I think is unfortunately set all the time, which is kind of an issue. We should be clearing that. So that could be part of the issue in and of itself. But anyway. Then we send a sense interrupt. Cool, whatever. Then we wait to see if we're at track 0. I'm wondering... Because the IRQ flag, the IRQ pending flag is set. Which probably isn't good. Like, it might not be waiting for it. Weird. Anyway, it checks it. Jumps to recalibrate loop. Does this whole thing. Decreases X. Blah, 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 blah. Is X potentially getting screwed up here? Because that's one possibility. Because it doesn't even really seem to be trying to. So I'm wondering if send FDC command, if I really boned some stuff up there. Wareroom said, is 8:30, is that later than usual? Need to know, because if so, I need to set my alarm to 4:30 a.m. 8:30 has been pretty much my normal time lately. Cliff Cheney says, wow, left work and you're still streaming. Yeah, that's why I gotta take off. I guess we will pick up here. I am bummed. This was supposed to be read a sector or bust, but I think it's a better idea that we structure our code better so that it will properly handle errors and whatnot like it should. It's the right way to go. It's the right way to go. Hey Dave. You came in right at the wrong time. I was just about to sign off. Sorry, my friend. But, you know, as said, tomorrow, 8:30. Anyway, code's restructured a fair bit. The only problem is it's restructured wrong. But that's okay. Dave says, as always, I'd say it's like 50% of the time. Sometimes you get in early. Anyway, yeah, I'm just going to call it because I have other things to do. But thank you guys for popping in. This continues to be frustrating, but, you know, baby steps. The funny thing is, for being a 2-hour stream, and Dave, you missed it, we had a successful read. We had a successful read at the top of the stream, so maybe it's fine. Yeah, this one is read a sector or bust. We read some sector data. Yeah, it's fine. It's good. It was like the first thing we did. We only read like 32 bytes of sector data or something. But, and then it complained about either an overflow or an underflow, which we're still not sure about. But then I decided to take Wareworm up on his recommendation to structure everything a little better and actually do error checking. And I think that's a good idea because at this point we're getting close to the point where we would actually want to start using this for various purposes, as in like implementing a DOS or something, where we're gonna want this to be structured and have error checking and whatnot. But yeah, the fun thing is when we get back to this, are we, especially with all of this extra error checking and stuff, are we gonna be way too slow? Okay, anyway, next time we will check in. I think it's probably, we got troubles with our send FDC command code, if I were to guess, in that it's probably sending and not really waiting for the ready for you to send me shit bit to change properly. And we're probably just rushing through this recalibrate loop and never properly sending the command, and yeah. So, anyway, Rob says 2:30 a.m. it is for me. Sorry, bro. You're always free to, you know, get some sleep some nights and watch the recorded version. Anyway, I gotta get out of here, as mentioned. So, finally, ranting over now that I've done the full recap. I will see you guys. Oh, you're there. You're right there. I have moved you. See ya. Love ya. Bye.